We have started. Uh, I selected a lecture which name is Units and Measurement. Units and Measurement. In details, we will cover this lecture as much as we can do. I want you with me. Stay till the end. I can guarantee you that yes, you will learn definitely. You will get valuable things from this lecture. Yeah, I can confidently say. Name of this lecture is Units and Measurement, and it is 11th standard. 11th standard. Yeah, you are right. We will start with the meaning of units and physical quantity. We will start with the physical quantity. Then we will see what is the dimension, what is the formula of dimensions of a physical quantity. All this will be covered. I cannot say only one, 4, 5, 6 topics. There are more topics in this lecture. All this will be covered. Whatever will be important from this perspective will be discussed with you. Topic wise we will be discussing one by one. Here, let me start. Physical quantity. It's not working. I want to write a physical quantity. Do you know what is a physical quantity? Do you know? If you know, then explain it. Physical quantity. Yes, it's look at here. Physical quantity. What should be meaning of a physical quantity? What should be meaning of it? According to you. According to you, what should be meaning of this? Let's see. Just for few minutes, give me some minutes, then I will write. I know that I wasted your this much time, but I apologize for this. I was not able to write anything because of this was not working. Now it's again not physical quantity. What happened here? I will use this one. No, physical quantity. Here, look at it. We have right now two words: physical quantity and unphysical quantity. But we will ignore unphysical quantity after understanding it. After understanding meaning of unphysical quantity, we will ignore unphysical quantity. Then our focus will be on physical quantity. So here, physical quantity is nothing but meaning of this is just any quantity you can take. Okay, you can take any quantity. Any quantity. If that quantity you are able to measure that quantity, then you can say any quantity you are taking. For example, A. Okay, this is a quantity. Let's say this is a quantity. Now we have two quantities. We have two quantities. Okay, A and B, two quantities. Now I am saying that yes, you are able to measure this quantity, but you are not able to measure this quantity. You are able to measure this quantity, but you are not able to measure this quantity. Okay. With examples, with real life examples, I will tell you. But right now, just understand that yes, this is a. Just assume that yes, it is a physical quantity, and this is another physical quantity. Here we are able to measure this, and but we are not able to measure this. In that case, we will understand the meaning of a physical quantity and meaning of an unphysical quantity. Now look at here. Any quantity you are taking, I don't care. Okay, I don't care. Any quantity you can take. But remember, if you are able to measure that quantity, then that quantity will be known as physical quantity. Okay, physical quantity. Any quantity which can be measured will be physical quantity. Will be physical quantity. Did you understand? Yes. If you are able to measure that quantity, then that quantity is a physical quantity. Now, let's take a real life example. Here, you know that yes, this marker, okay, this marker. Can you measure this marker? Can you measure? Yes, you would say yes, it can be measured. So this is a physical quantity. Here we can measure it into length, isn't it? Yes, that's why length is a physical quantity. So here length will be example. For example, length, mass. We measure mass in kg. Okay, you know. There are more physical quantity. I hope you have understood meaning of a physical quantity. Anything, any quantity you are taking, you can measure that quantity. Then okay, you can keep that quantity in the category of physical quantity. But what about this quantity? What about this quantity? Yes, some of you would be thinking, yeah, this is nothing but just an unphysical quantity. Yes, you are right. But how to define? This is crucial. We have defined. We have defined. We said yes, this is quantity which we are able to measure, but this is not quantity. This is also quantity, but we cannot measure this quantity. So it will be kept into another category, and that category is an unphysical quantity. That category is an unphysical quantity. So any quantity which is not measurable will be known as an unphysical quantity. Unphysical quantity. No, real life example. Here, hate, love, all these are unphysical. We cannot measure this. We cannot measure this just by using tape. Can you say that yes, this much kg love, this much kg hate? No, it is not making sense, isn't it? So all this will be known as unphysical quantity. Okay? Right now you have understood meaning of this and meaning of the unphysical quantity. Now we are able to move ahead of it. Now next, ahead of it we understand. Ahead of it we understand fundamental quantity and derived quantity. Fundamental quantity and derived quantity. But let me explain about the unit. Unit. After understanding unit, we will see fundamental quantity and derived quantity. Okay, don't worry. So here unit. Unit. What is the meaning of unit? What do you mean by unit? This is nothing but this is a combination of, yes, meaning of this is what? This is a combination of a magnitude and unit. Yeah. Not this is not math. Here it is just it tells you that yeah, you are measuring this, that, this, that. For example, if you measuring length, then here is unit of length. You know that unit of length is meter. So when you write meter with number, then you are able to convey. You are able to say that yes, I am measuring something length of object. For example, for liquid, we know that for liquid unit is a liter. So when we will say yes, 1 liter, 2 liter, 5 liter. So here we other person is able to understand yes, you are measuring a liquid material, and other person understood because of you said you used unit. Then only if you speak only number, then nobody will be interact with your word. For example, only you say only 1, 2 or 4, then people will be confused. What do you want to say? People will be clear when you will be using units. Okay, when you will be using units, then people will be clear, will be able to understand yes, this is what you are saying. Okay, so why do we use units? We use this so that anybody can understand our message. Okay, clear? Okay. We have a lot of topics regarding this unit and regarding this physical quantity. Don't worry. In details, we will be explaining about it. Next, magnitude. Magnitude. Little word I am explaining right now so that your basic can be complete. Not too much basic, little bit basic. After this completing, magnitude. Magnitude. What do you understand by this magnitude word? Yeah, now I can say that yes, this is a combination of unit and number. Okay, this is a combination of a unit and a number. Yes, you are right. Number units. For example, 5. 5 is a number. Now, where is a unit? Let's use unit meter. 5 meter here. Now it is a complete magnitude. How can we say that yes, this is a complete magnitude? Just to be understood, definition of magnitude. We said that yes, this is a combination of a number and units. So here you can say that yes, 5 is a number and m is a unit. That's why this is evidence. Evidence is that the definition of magnitude explains that we will have a number with unit. That's it. That's it. Okay. So remember, only don't write only number. Okay, don't write only unit. You will have to use both unit as well as number to define magnitude, to show a magnitude. Clear? Magnitude is nothing but just it is a combination of number and unit. Clear? Yeah, unit can be anything. It can be liter, it can be Newton, it can be anything. Okay, here we are taking unit. Number can be any length. Okay, 5,000, 5 lakh, any number. We will link this with our this upcoming topics. Okay. Okay. Now we are able to understand the fundamental quantity and derived quantity. Clear? Derived quantity. Some topics we have discussed, we have understood. Now let's see fundamental quantities and derived quantities. Look at here. It's not working now. Here we have a fundamental quantities and derived quantities. First of all, let's understand meaning of a fundamental quantity and meaning of a derived quantity. These are quantities. Okay, here I will write some quantities that will be fixed, but these are not fixed. These are not fixed. There are a lot of derived quantities. I have told you what is the quantity. We are talking about physical quantity, not unphysical quantity. I have told you before that yes, I will ignore unphysical quantity because our focus should not be on the discussion of unphysical quantities. Okay, in this we took what units and measurement lecture. That's why our focus should be on physical quantity. And whenever I will be now whenever I will be saying quantity, then just understand, yes, I am saying physical quantity. Clear? Here fundamental quantities, there are seven quantities which are fixed. But when you will come in this, then there are a lot of quantities. Clear? Clear. All these seven quantities will be what? uh, will be independent. But what is independent? What is the meaning of independent? All this will not be depend on this quantity, on another quantities. Okay? But all these derived quantities will be depend on fundamental quantities. Clear? What I am saying? I am saying that this fundamental quantities will not be depend on another quantity. It will make itself quantities by not depending on another quantities. But these quantities will be created by using fundamental quantities. Did you understand meaning of fundamental quantities? Definition of derived quantities? Yeah. Now I am going to write those seven physical quantity, and I know that most of you are familiar with this few fundamental quantities. Can you tell me name of those fundamental quantities? Yes, I'm going to write. Let me write. First is nothing but just length, then mass, Look at me. I have wrote all this. Now we will explain this. Look at over here. Here I wrote some fundamental quantities with as well as units are written over here. Units. These are units. Now symbol of this meter is what? M. This kg and this s. This k. This is m. All these are symbols of units, and all these are units. All these are quantities, fundamental quantities. I told you that all this will be fixed. All these are fundamental. Now just count this. 1, 2, 3, 4, 5, 6, 7. From here to till here, I was talking about this. These are supplementary quantities. Okay, these are supplementary quantities. There are two supplementary quantities which are fixed, and all these are fundamental. Even you can say that yes, these are fundamental quantities, but name of this quantity is a supplementary quantities. Clear? This is your choice. If you wanted to consider all this as a fundamental quantity, then you can say. I am not saying that don't always say that these are fundamental quantity. It is your choice. Now, let's see. You know that length. What is the length? Length. Just we measure. You will measure this. Then you will get in a length. Yes, this is 5 meter, 5 centimeter. Meter is just a part of a centimeter, isn't it? So here, when you will measure this, then you will get, you are measuring length of this marker, and then in result you will get this much meter, this much centimeter. You know that meter is used for small things, but kilometer is used for long distance, for long, yeah. Now next we have mass, kilogram. We are not talking about kilometer, yeah. We are talking about kilogram. It means we are measuring something, measuring of mass of object. For example, what is the weight of this object? Weight, mass. What is the mass? It can be 5, 6 gram, 10 gram, at least 10 gram. Mass of this object should be 2 kg, 500 gram, yeah, this much. So that is how we say yes, this much is the mass of this object. Okay. So unit of mass is what? Kilometer. Not kilometer, kilogram. Kilometer is for length. is for length. Now next we have fundamental quantity, which is a time. As a unit of a time is what? Just in little. More little. Second, then meter, then hour, minute, hour. So SI unit is what? Second. For that. Next we have temperature. You know what is it? Heat. Measuring of heat of object is just a temperature. Is object cold or hot? Just by using thermometer device, you will be able to measure temperature of that object, and in you would say yes, this much Kelvin. When you say yes, this much Kelvin is a hot, this body, you are saying that this much hot, this much cold. Even you will see Fahrenheit, Celsius, all this about in the discussion of a temperature. But right now we are not going to into too much of details about the temperature. Just we are observing units, quantities, symbols of units. That's it. Okay. Next we have symbol for electric. No. Symbol for temperature is what? K. First letter of a Kelvin is a K. Next we have electric current. This is a separate lecture we know, but I told you that we are not going into details about all these fundamental quantities. Yeah. No. So electric current. What is the unit of electric current? Just ampere. You know that? I'm not saying ammeter. Ammeter is used. This is ammeter is a device. You know that, yeah? You know that yes, ammeter is a device and it is used to measure current. Yeah, you know. But here we have ampere, and ampere is not a device. This is a unit of electric current. Okay, this is a unit of electric current. So remember, unit of electric current is nothing but just ampere, and symbol for ampere unit is just first letter of ampere word, which is A. Whenever you will use A in the context of electric current, you are saying that yes, this is a no, not a habit. This is ampere. It means you have electric current. Okay. Now next we have number of particles. Number of particles. About this you are taught in chemistry subject. Okay. Number of particles. Mole, atoms. Number of atoms. So number of particles. This is a physical quantity, and unit for this is a mole, and symbol for this is a mole. This is a mole. Now next we have luminous intensity. We will not have a separate in details about the luminous intensity. No. Sometimes you will see that this is a coming. Sometimes you will see. You just say that yes, this is a physical quantity, and unit for this is a candela. Symbol for this is just a CD. Clear? CD. These were 7 fundamental quantities. Apart from this, we have 2 more, which are supplementary quantities. First, we have plane angle. We are familiar with plane angle, but we are not familiar with the solid angle. Okay. If we are not familiar with the solid angle, it doesn't mean that we will ignore it. No, not at all. Rather, we will understand it. Plane angle, you know that, just a coordinate plane. Okay, Cartesian plane, not plane. Then we will draw a circle. Just a arc. You know that theta is what? L upon R. L is the arc and R is the radius. To get theta, you will use L upon R, and to get L, you will use theta into R. Isn't it? L is nothing but this is an arc. We draw a circle on on a Cartesian plane. Cartesian plane is nothing but just this is a two lines. This is known as x. This is y axis. Look at it over here. From here to here, you know that this is radius. One more. Now this is giving you a rotation. And from here to till here, this will be known as nothing but just r. And here we are representing it as a L. Clear? To find out the measure of this length, we will use this formula. Both are same, not same. It came from this. Okay? So this was meaning of this plane angle, the radian. You know that radian is nothing but this is radian. Remember, I know that you are familiar with the degree. 360 degree is nothing but just a one revolution. 3 degrees is just a one revolution of a circle. So remember, how much radian is equal to 360? How much radian? So remember, 2 radian, 2 pi radian is equal to 360. And here pi is nothing but 1 pi is equal to 1 pi is equal to 180 degrees. So you will get 200. Both are equal. Both are equal. So that's why here you can say 2 pi radian is equal to 360 degrees and 180 is equal to 1 pi. Clear? 1 pi radian. 1 pi radian. So this from here, this half is a 1 pi and this another is a another pi. You go to 2 pi. So this radian is nothing but we are talking about this. Okay. And details we will see in a separate lecture. Now let's understand about the solid angle. Solid angle. Start here. Remember here, this is also angle, but here you will have angle in 3D. Remember, here it is talking about angle which is in 3D. You will get a cone, okay, a cone like that, cone. But you know that this is a 3D. It is talking about this angle is not nothing but just this angle, this angle. This is solid angle. And we are talking about this is solid angle. This is solid angle. Clear? This solid angle. It is not like that. Rather, it is like that. Clear? This is a plane angle, but this is a solid angle. Solid angle, which will give us in 3D. In 3D. Now here, unit for a plane angle is a radian, not a degree. This is the standard. It is a standard. So unit for plane angle is a radian, and unit for solid angle is a stadian. Okay. Symbol for radian is a RAD, and symbol for stadian is a SR. Just SR. Now we are crystal clear about the fundamental quantities. I hope you are also crystal. All of you are crystal clear. Now tell me, can I move towards the derived quantities? Derived quantities. I want to discuss about the dimensional quantities. Dimensional. Derived quantities, I can explain about it. Look at over here. Look at over here. I am talking about derived quantity. You know that this is it is a depend on what? It is a depend on fundamental quantity. You are you know. So remember, we cannot say that length is a derived quantity. No. It is independent. It is independent. Okay, not a dependent. So here, derived quantity is nothing but just distance, velocity, speed. I left one thing is that about scalar quantities and vector quantities. I will explain here. Okay, I cannot ignore this here at all. A scalar and a vector. Clear? Vector. It cannot be ignored at all. At all. Now, here these are derived quantities. We are driving this quantity. That's why the name of this is a drive quantity. Then force we have force. Uh, there are momentum more unlimited. Okay, we can. There are a lot of drive quantities. Here, one thing you will observe that all these drive quantities will depend on fundamental quantities. This is what you will observe automatically. With proof, I will show you. Here, let's take this. Okay, distance. Here, just if we take length, only we are getting m, not another also. With this, another quantity is not coming. But in this, you will observe that we will take one quantity, but another quantity will also come. Distance here, we know that. What is the unit of a distance? Hold on. Meter per second. Meter. No, we can. I am not confirm about this. This speed, okay, speed and velocity. Speed and velocity. Tell me, what is the formula of velocity? All of you know that is formula of velocity and speed. For both are same. All of you know. Now here, velocity, it is nothing but just displacement upon time. Displacement upon time. Yeah, you know. Here, unit of 4. Now our focus should be on units of physical quantity. Now unit of 4 displacement would be what? Meter, and for time second. You are getting what? Meter per second, isn't it? Meter per second. Now look at here. Not only one quantity is coming, but also one more quantity. More than one quantity is coming, then that one quantity is what? Is a drive quantity. Look at here. Meter is one quantity. Second is also another quantity. Two quantities over here are coming. That's why here this is depend on fundamental quantities. Here meter, second. All these are fundamental quantities, and by using m and s, it created another quantity which is a velocity, and we know that this is nothing but it is a drive quantity because it was created by using fundamental quantity. Clear? Fundamental quantity. You know that this is also it just a distance upon time. Distance upon time. Same meter per second. Okay. We will see what is the dimensional formula for this quantity after completing this. Now look at here. Meaning of a scalar and meaning of a vector. I have told you meaning of a magnitude. So a scalar is just magnitude. It is a quantity. A scalar is a quantity. Clear? A scalar quantity. A scalar is a quantity. Why is it compulsory to understand a scalar and vector? Just let me complete a definition of this both, then I will tell you. You will get understand automatically. Here, both are quantities, but some quantities will be kept in this category and some quantities will be kept in the category of vector. So now we are going to define all those quantities which will come in this category and all those quantities which should come in the category of vector. So any quantity you are taking, but that quantity is not giving you, that quantity is not providing you direction. Okay, that quantity is not providing you direction, then that quantity will be kept in the category of a scalar. Okay, a scalar quantity. So here we have a distance. It is not providing you direction. It is just giving you magnitude. And magnitude is nothing but just a meter, a unit with a number. This 5 meter is what magnitude. So any quantity which is providing only magnitude will be known as a scalar quantity. Any quantity here, velocity is a scalar quantity. Velocity is a vector quantity. Vector quantity. Clear? This is a vector quantity because it provides a direction. This provides. What's the difference between a velocity and a speed? Both are same, but there is one thing which make difference between is that is just a direction. A speed, as you know that a speed does not provide direction, but velocity provides direction. Formula for both are same, but difference is that a speed is not able to provide direction, velocity is able to provide direction. Clear? Yeah, that's why velocity will be known as a vector and the speed will be known as a scalar. Clear? Force is also a vector. Okay, don't say that force is a scalar. Force is a vector. When you apply force, then you see that yes, in this direction you are applying force. In this when you lift something, then you see that yes, your direction is upward. Your direction is upward. Your direction is downward. Your direction force is just a downward force. Okay, you know, Beyonce is upward force. So all these are direction, upward, downward, forward, nextward, backward, all these are direction. North, south, east, west. Yeah, you know that all these are direction. Okay. So magnitude definition of vector is what? It gives you, it has a magnitude as well as a direction. Yeah, direction. Okay. Okay. So these were derived quantity. Now all some derived quantities we will take and we will see a dimensional formulas for all those quantities. Just have a look. Then I will write some derived quantities. Just have a look. Let me write all this. I will write some derived quantities as well as dimensional formulas of all those derived quantities. Now let me write. No, we have 5. Dimensional formula is nothing but here you are saying, you know that we can measure this in meter, in kilo, in what, in centimeter, in millimeter. There are a lot of units for this, but we will take here only one, which is length. Okay, length. Here one, first of all M, then L, then P. M for mass and L for length and T for time. By using this we will write a dimensional formula. By using this we will write a dimensional formula of all this physical quantity. By using this. So M would be for mass and L would be for length and T would be for time. Okay, only 3. Only 3. Here all this we are taking because of it will decide only one thing, this will decide only one thing, it will. Here by taking length we are not taking centimeter, meter, millimeter, all this, okay, meter, all this, no. Only we are taking L. There is a mass, there is a time. That's it. For time we know that our time, our minute, second, there are three units. But rather than taking this much units, we will take only one time. And by taking time, we are saying just this is a 4. time. Now here we have displacement, first quantity. So what should be dimensional formula for this displacement? First of all, you need to know what is the unit of for this displacement. You know that for this is nothing but just meter. Meter is a what? Meter is a length. And here only we have length. Okay, only we have length, not mass, not top. If there is no mass, just use exponent 0. If there is a 1, then use 1. Okay. For example, here we have 1 meter. 1 meter. So we know that m, there is no mass in for this displacement. So m here would be, exponent would be 0. Then we have L. L is for length. L is for length. L is how much? 1. And we know that 1 is the hidden, but right now I am writing 1. Okay, I am writing 1. So that just for 1, for the starting. Next we have T. There is no time for displacement. There is no time for displacement. Hold on. Yeah, we don't have. Yeah, right. So here you will write 0. This is your complete dimensional formula for your displacement. And just surround it by using a square bracket. This is how we write a dimensional formula for a physical quantity, and that is how you will write dimensional formula for physical quantity. Clear? Are you understanding? First of all, you will have physical quantity, then just write units of those physical quantity, then you will be able to create a dimensional formula for those. Next we have area. What is the unit of area? Meter, yeah, area. Meter square. For volume, meter cube. Yeah? Do you know? Now, here we have meter square. Meter is 2 times. But not mass, not time. We don't have mass, we don't have a time. So for mass, it should be 0. Length, meter is 2 times. So here exponent 2 would be 2. P is 0. This is your dimensional formula for this area. In this you are saying that mass is nothing. There is no mass. There is a length, which meter is 2 times, and there is no time. Clear? Now for volume, this is an m cube. Here you are saying that L is 3 and T is 0. Clear? For next, velocity. It is nothing but just a displacement upon time. Yeah. So what should be displacement? For displacement, we know that meter and per second. This is the unit of velocity. In this we are observing that we have 1 meter and we have 1 second, but the second is a denominator, which means here for velocity would be what? First of all, m is 0. Yes. And here L we have 1 and T is 0, not a 0, T is 1. But this is it is in denominator. When we will bring this here, then what will happen? 0, L, 1, T raised to power minus 1. I think it should happen. Yes, this is correct. Here we applied -1 because this t is a denominator. To represent anything which is a denominator, just we will write here -1. Now it is in numerator. So dimension formula for velocity would be nothing but m is 0, m is 0, and l is 1, and t is -1. Here you know that this is a minus m meter per second. Meter per second. Clear? Clear? Are you stay clear? For next, we have acceleration. Acceleration is nothing but just it is uh, a meter second raised to power -1. This is the unit for acceleration, you know that. Yeah. Otherwise, you can say meter per second as well. Meter per second square. But when you will remove this divide, then it will here this will come -2. This will come -2. And here you are saying that m is 0 and l is 1 and here t is a -2. That is what you are saying. m0, l1, t -2. T -2. Now next we have density. Next we have what? Density. Density, you know that it is nothing but just a kg meter raised to power. Otherwise you can say kg per meter cube. This is unit for density. Density. It has mass. It has mass. For density, here we have kg, which is a mass. So you can say what? Exponent of kg is 1. This one. We have L, but it is in negative. So L raised to power -3. No, we don't have a time. For time, exponent would be 0. This m1 L -3 is 0 is a dimension formula for density. For density. Just look at it over here. Four more. I will not stop here. 4 more. Okay? Look at over here. After density, we have momentum. Look at over here. I wrote 5 more. There are two twists. There are two twists. Would you like to see? First of all, here we have momentum. What is the unit for this momentum? We know that mass multiple acceleration. M A, but it is a force, yeah. Mass multiple acceleration. M A. Kg meter per second. So here we have kg meter per second. Kg meter per second. This is the unit for. Here we have this kg m, and it is nothing but momentum is formula for momentum is what? Mass multiple velocity. Yeah, not acceleration. Mass multiple as velocity. It is what? M multiple v. Now look at over here. Meter per second is for velocity and kg is for mass. Okay. Here we have one mass, and we have velocity. What is the dimension formula for velocity? We know that. If you don't know, then don't worry. We can create from scratch dimension formula for this momentum. If we don't know dimension formula for velocity. Here, look at it. Kg m. This is a mass. M is a 0. Okay. Meter L 1. L 1. Look at over here. It is not 0. This is 1. Next we have S, which is a time. Time is how much? This is also 1, but it is a negative. It is a negative, which means this is in denominator. It is a complete. This is a complete dimension formula for moment. M1 L1 T minus 1. M1 L1 T minus 1 is a dimension formula for momentum. Clear? For velocity, what do you want? M0 L1 T minus 1. Here. M0 L1 T minus 1 for velocity. Okay. This was not a twist. Twist is coming after. Twist is here. Twist is here. What is the unit of work? You would say joule. Not joule. Joule, yes, joule, kg. Joule or kg. Joule or kg. This is unit. This is unit. Complete unit for work. Twist is that this is also unit for energy, and this is also for heat. Okay. Whatever I will write here dimension, it would be for also work, for also energy, for also heat. Okay. So this one dimension will be equal to this. So here, joule, which means kg. Okay, joule, which means kg. This joule can be written as kg meter square per second square. Okay. Here we have 1 kg, which means m1. Then meter square, which means L2. Then 1. I think 1. T is a 1. Is it correct? This is incorrect. It is a minus 2. This is a minus 2 because of a square, and that square is in denominator. That square is in denominator. So here kg is this kg for kg m1, for meter square l2, and for second square t minus 2. It is in denominator, that's why here minus came. Now next we have power. There was one twist will come over here in the angular velocity. Here power. What is the unit of power? Power. What? Yeah, what? Or you can say joule per second, or you can say joule per second. Joule per second. Watt. Otherwise you can say joule per second. Both are not same. Work and power both are not same. Okay. Joule is coming in this, but it doesn't mean that both will be same. Here power, watt. Okay, this is watt. Now we know that what is the dimension formula for joule. We know. Just we will add. This is second. One more. So for joule, we know that m1 L2, and this is minus 2. There are one more. So for one more minus. This is a complete dimension formula for power. m1 L2 t raised to power minus 3. For angular velocity, unit for this is radian, but s minus 1. Radian per second. For angular velocity, unit. What are you observing? For angular velocity, here unit for this angular velocity is radian per second. Otherwise you can say radian s raised to power minus 1. Both are same. Okay, both are same. Second twist is over here. Yeah. Here, remember, supplementary quantities will not give you dimension. Okay, supplementary quantities will not give you dimension. It does not have dimension. Here, stadian will not provide you dimension. Clear? So here you will ignore this radian. Here, radian and stadian will be ignored because it does not provide a dimension. It does not have a dimension. That's why. Clear? So here we are ignoring radian. This is rule. I cannot say any more about this. Now next whatever we have, we know that this S, it is not supplementary. Yeah. So here would be what? First we have M, which is 0, L is 0, T is minus 1. M0, L0, T minus 1. Now unit for angular acceleration. For this S raised to power minus 1 radian per second, but for this radian per second as well. Radian per second as well, or radian sec minus 2. Dimension formula for this would be what? M is 0. Yes, M is 0. L is 0. Yes. Here radian will be ignored. You know. Okay. Now T is a minus 2. So finally, dimension formula became for this is what? M0 L0 T minus 2. T minus 2. Did you enjoy? Okay, all these are clear. This is looking amazing for me. Okay, for now that's all. Just this was for a discussion, and In separate lecture, we will have a lot of dimension quantities just for little bit understanding. Okay, just for little bit understanding. And in separate lecture, I will bring all those dimension formula of all those 50, 60, 90 physical quantities. Okay. In next lecture, we will see. We will see.